Good day, everyone. For today, we are going to discuss a new lesson. But before that, let's have a short recap about the discussion we had last meeting, which is about the normal distribution. By definition, normal distribution is a data distribution wherein the mean, median, and the mode are equal and is clustered at the center. The graph of a normal distribution is a symmetric bell-shaped curve which is called as the normal curve or also known as the Gaussian distribution. Now let's have the properties of a normal curve. First property, the graph is a continuous curve with the domain x is less than positive infinity but greater than negative infinity, which only means that the value should be in between negative infinity and positive infinity. Second, the graph is asymptotic to the x-axis. When you say asymptotic, the curve gets closer and closer to the x-axis but will never touch. Third, we have the maximum point on the curve occurs at x equals mu or the mean of the distribution. Fourth, we have the graph which is symmetrical about the line x equals the mean, which implies that the mean is located at the center and the line of the demarcation divides the whole region into two halves. Now let's have the fifth property. The median and the mode of the distribution are also located at the center of the graph, which only means that the value of the mean, median, and the mode are equal. Next, the area under the curve bounded by the x-axis is equal to 1. Now, since the mean or the demarcation line divides the curve into halves, then that only means 50% is the total area of the curve on the left side and 50% on the right side. Next, the standard deviation affects both the width and the height of the curve. In terms of the width, the bigger the value of the standard deviation, the wider the graph. The smaller the value of the standard deviation, the narrower the graph. In terms of height, the bigger the value of the standard deviation, the shorter the graph, and the smaller the value of the standard deviation, the taller the graph. Let's have the last property. The standard deviation precisely describes the spread of the normal curve. In fact, approximately 68.3% of the values in the distribution are within one standard deviation away from the mean. 95.4% is within two standard deviation from the mean, and 99.7% is within three standard deviations from the mean. Now let's have the mean and the standard deviation of a normal distribution. Let's have this example. Solve for the standard deviation of the normal distribution where 99.7% of the values fall between 52 and 82. To solve for the two values, we have to follow a two-step procedure. Step 1 is to solve for the mean. Now, mean is computed by adding the two values and divide it by 2. So we have mu, which is equals to 52 plus 82 divided by 2. And the mean of the distribution is 67. The second step is to solve for the standard deviation. Now, take note that there are different formulas in solving for the standard deviation depending on the given area. In the problem, the given area is 99.7%. Therefore, the formula to be used in solving for the standard deviation are as follows. Mu minus 3 standard deviation equated to the smallest value to get the left side, and mu plus 3 standard deviation equated to the biggest value to get the right side. Substitute the values, simplify and solve, then the standard deviation of the problem is 5, which only means in the normal curve we have 52, 57, 62, 67, 72, 77, and 82 as the values. And now let's discuss the standard normal distribution. Standard normal distribution is a special case of the normal distribution. It is the distribution that occurs when a normal random variable has a mean of 0 and a standard deviation of 1. To differentiate the two distributions, when we say normal distribution, the mean and the standard deviation could be any number, while in standard normal distribution, the mean should always be 0 and the standard deviation should always be 1. Then we go to standardizing the normal distribution. Standardizing is the process of converting a normal distribution to a standard normal distribution. In fact, any normal distribution can be converted into a standard normal distribution using the values or by turning the individual values into z-scores. What is a z-score? Z-score is also known as the standard score. It is the equivalent value of a raw score expressed in terms of the mean and standard deviation of the distribution. It measures the distance of any raw score from the mean in the standard deviation units. It is calculated using the formula z is equals to the raw score x minus the mean all over the standard deviation, where z is the z-score, x is the raw score, mu is the mean, and sigma is the standard deviation. To have a better understanding about the z-scores, let's have the following problems. Problem number 1. A random variable x has a mean of 4 and a standard deviation of 2. Find the corresponding z-score for x equals 7. Identifying the given, we have the raw score x, which is 7, the mean, which is 4, and the standard deviation, which is 2. To solve for the z-score, we have to use the formula z equals x minus mu over standard deviation. Substitute the values, we have z equals the raw score x, which is 7, minus the mean, which is 4, all over the standard deviation, which is 2. And combine like terms, simplify the numerator, we have 7 minus 4, the result is 3, divided by 2, the equivalent z-score of 7 is 1.5. Now let's have the normal curve. Let's plot 1.5 and it is located in between 1 and 2. Therefore, from the mean of the distribution 0, the shaded portion is from 0 to 1.5. Problem number 2. A random variable x has a mean of 1.3 and a standard deviation of 0.5. Find the corresponding z-score for x equals 1.85. Identifying the given, we have the raw score, which is 1.85, the mean, which is 1.3, and the standard deviation, which is 0.5. Use the formula. Substitute the values. We have z equals 1.85 minus 1.3 all over 0.5. Simplify the numerator. The result is 0.55 divided by the value of the standard deviation 0.5. The equivalent z-score of 1.85 is 1.1. And plotting it in the normal curve, it is located somewhere here. And then if we are going to shade the region under the curve, the shaded portion is from 0 to the value 1.1. And we are down to our last example. Let's have problem number 3. A random variable x has a mean of 5.2 and standard deviation of 2. Find the corresponding z-score for x equals 3.72. Identify the different given. We have the raw score, which is 3.72, the mean, which is 5.2, and the standard deviation of 2. Use the formula. Substitute the values. simplify, and the equivalent z-score of 3.72 is negative 0.74. Now, if we are going to plot it in our normal curve, since it is negative, therefore, it is located on the left side of the mean. So it is somewhere here. And the shaded portion under the curve is from the value negative 0.74 to 0. And that's it for our discussion for today. Thank you for listening.